Hello dear students, this is problem number 16 of engineering mechanics statics chapter 4 ninth edition. Okay, so in this problem the rectangular frame is composed of four parameters. Two force member, two are the force member and two are in this frame. There is a two force member and two cable. Okay, two are the cables which is AC and BD, which is AC, this are cable, and BD, it is also a cable. Okay, which are incapable supporting compression, which cannot support compression, these cables. Okay, determine the force in all members due to the load L in position A. If I will take L load on position A, or if you take load in position B. So our goal is to determine the forces in these members, whether the load at this point at joint B. We in first case we analyze and we determine all the forces in all members if the load at joint B, and also we analyze all the member forces if the load acting at joint C. Okay, so first of all, we need to find the reaction force from the equation of equilibrium. Okay, so first of all we need to draw a free body diagram of this truss. So I can draw. I will find the reaction force in this diagram. It's okay, but in exam and in your assignment you don't have to do that, because you first of all you draw a free body diagram and you cannot write and cannot draw these forces at the place of this. You have to only draw a reaction forces. Okay, you can't draw these reactions, these supports. Okay, so summation, there are three equation of equilibrium by which we will find out the reaction forces. So first of all, summation of all horizontal forces acting on this truss equal to 0. So there is two horizontal forces, AX and DX. So AX directed toward left, which will be negative, and DX directed toward the right, which will be positive. So DX, positive DX minus AX will equal to 0. This is our equation 1. And the second equation is summation of all vertical forces acting on this truss equal to 0. So there is only two vertical forces, which is AY and L. In case A, there is only this load. So these two forces are vertical forces. Okay, so AY, which is directed upward, positive AY, minus L, which is directed downward. That's why I put here minus, equal to 0. So the third equation of equilibrium equal to summation of all moment acting on any point, which will be which we can fix at any point, summation of all moment at a point equal to 0. So I let's say that summation of all moment at point A equal to 0. I fix point A. You can fix any point in this truss. Okay, so this will be easy for us to fix point A to find moments. Okay, so moment equal to RF, radius into R, distance into force. So this is the force dx, which is this, which rotate this truss, which try to rotate this truss anti-clockwise. So dx into distance from A, dx into 4D. This is the distance and this is the force, reaction force. So dx into 4d negative L, which is this, L into distance is 3d. Okay, so L into 3d equal to 0. Let's say this is equation 3. So in equation 3, if you calculate this and move all known values to the right side, dx will equal to 3 divided by 4L, which is equal to 0.5 load. The dx will equal to 0.5 load. How much load? It is the generalized equation. If load is equal to 100, then the dx will be 100 kilonewton. Then the dx will be 75 kilonewton. If the load is 1000 kilonewton, then the dx will equal to 750 kilonewton. Okay, so this is the generalized equation. Okay, question. So if I take equation 1, so dx is negative ax equal to 0, dx will equal to ax. So dx equal to ax, which is equal to 3 divided by 4l. Ax is also equal to 3 divided by 4l. So if I take equation 2, so ay equal to negative equal to L. So ay will equal to L load. If the load is 1000 kilonewton, then ay will also equal to 1000 kilonewton. So ay is equal to the load. Okay. So in first case, in this case, if you take a case that if we take this as it is the load acting on joint B, in this case we will find forces in these members. Okay, so I take case 1 and take a joint B and draw a free body diagram of joint B. So at joint B there is three forces, which is 1 force, 2 and 3 forces acting on joint B. This is this force, the force in member BD equal to 0. The force in member this in this cable, the force will in this cable will equal to 0, because the there is shown in the question the two cables are incapable of supporting compression. When the load is here, the truss will move downward like this. Then the force in this member will be compression force, which are incapable and which cannot resist reaction force. That's why we say that force in this member BD member equal to 0. Okay, so I will take summation of all horizontal forces acting on this joint B equal to 0. So there is only one force, horizontal force, FBA equal to 0. So and negative FBA equal to 0. So FBA, there will be no force in member BA in case A. Okay, so summation of all vertical forces equal to 0. So FBC negative L equal to 0. So FBC will equal to L. Okay, there will be force of load in member FBC. If the L is 1000 kilonewton, then the force in BC will be 1000 kilonewton. In this member will also be 1000 kilonewton. Okay, so the another joint I want to analyze is joint D. So there is three forces acting on joint D. Now I take summation of all vertical forces equal to 0, which is only one force. So FDA will equal to 0, and the summation of all horizontal forces equal to 0. So negative FCD, which is this force, and positive DX equal to 0. So FCD will equal to DX, which is DX is already I calculated that 3 divided by 4L, which is so the CD force in member CD will equal to 0.75, which is equal to 0.75 L. Okay. Now I want to analyze joint C to calculate forces in this all members. So uh, if BC there is three forces acting on this joint, and I calculate this angle from the tangent theta, you can say that you can calculate it by using tangent theta equal to 0. So if I find this angle, for example this angle is alpha, so tangent alpha equal to opposite side is this, which is 4D by adjacent side 3D D is cancelled with D, so alpha will equal to tangent inverse 4 divided by 3, which is equal to alpha equal to, if you calculate this, alpha will equal to 53.13 degree. This will be 53.13 degree. Okay, so I take summation of all horizontal forces acting on this joint. So there is only one horizontal, so there is two horizontal force. One horizontal force is the component of FCA, and the other horizontal force is FCD. So FCD is FCD, which is directed to right. That's why I take it FCD, positive FCD, negative FCA cos 53.13 equal to 0. So FCA will equal to FCD divided by cos 53.13. So FCD, at the place of FCD, it is a 3 divided by 4. The value of FCD is equal to 3 divided by 4L into 1 divided by 3, 1 divided by cos 53.13. So if you calculate it on your calculator, so the result will comes f of FCA is equal to 1.25 L, which is in tension. I assume that this force FCA are in tension. That's why the answer with a positive sign means that my assumption was wrong. My assumption was right. Sorry, my assumption was right. It is in tension. Okay. Now I want to analyze all the joints on case B. So if the load is act on joint C, then how much force on this member, this member, and this member, this member, okay, and this member. So now I also want to take joint B, summation of all horizontal force equal to 0. So there is only one force, which is FBA. FBA equal to 0. In this case also ABA is also equal to 0. So summation of all vertical force equal to 0. So FBC, there is this force only FBC. FBC is also equal to 0. Now I want to analyze joint C. So at joint C there is 4 forces acting on joint C. Summation of all horizontal force equal to 0. So FCD negative FCD, which is this force, negative FCA, which is FCA cos 53.13 equal to 0. FCD will equal to FCA cos 53.13. So FCD at the place of FCA, I put here its value, which is 1.25 L multiplied by cos 53.13. So FCD will equal to 3 divided by 4L. Okay, which is in compression. I assume that this FCA is in FCD is in compression. That's why the answer with a positive sign means that my assumption was right. It is in compression. Now summation of all vertical forces equal to 0. So if CA sine 53.13 negative L, which is this forces, FCA which is this for FCA 50 cos sine 53.13, and this FBC, negative FBC, and this negative L. Now I want to take joint D. In this joint there is three forces acting on it. So summation of all vertical force equal to 0. So FDA will equal to 0. There is only one vertical force which is 0. So the forces which load a member in case A, which is act on members of the truss in case A, which is equal to FBA is 0, force in member BC equal to L. Okay, force in member CD equal to 3 divided by 4, which is equal to 0.5 L, 0.75 L. So FCA equal to 1.25 L, which is in tension. So FDA equal to 0. Now there is no force acting on FBC. In case B, if the load is at joint C, then there will be no force in member FBC. Okay, this is the safest case when we apply load on joint C. This will be safe case for us. If I uh, apply load in this joint, this will be the safe case because there will be no force in this joint. Okay, so we have found all these forces. Thank you very much.